Hmm. Hey Tarun,
Oh, hey JP. Sorry I'm late.
no worries. How are you doing?
Yeah. Good, good. How are you?
I am good, Tarun. So Tarun, this is a quick one. I just want to sync up with you on the
Uh-huh.
FPGA board order. So what you're
Yes.
saying is the board is not available immediately and we cannot order it, correct?
Yes. Yeah. I mean, the thing is like how it works is like Fermilab runs time to time they run like 20, 30 boards of order.
Mhm.
And basically usually like they do it like once every 4 months or once every 5 months, and like we have to get on the list for the next one if we want to order it. And then they will basically whenever they manufacture those boats, they'll just send us the boats. And the way it works is we have to pay for Milab directly. And from what I understand, that's a complicated process, and it's going to take like few months to get that
Oh,
done.
I see.
Yeah.
Okay, I think Trent is saying that he can order FPGAs, right? So
Yeah.
I think that's a good idea. Anyway, we would need FPGA,
Hmm.
right? He can use that money to buy the FPGA. That same FPGA board is used.
Correct. Yes. So that's the one. I sent the link. So basically, I spoke to Marcos here, and he has like a few boats. Usually, like how, because Marcos is one of the designers, he uses these boats like frequently in like most of his projects.
Okay.
So it's like whenever whenever Formulab designs like manufactures the boats, like they usually like send him like few bare boards, and he will like populate them. And then like he has like four such boards which were like completely populated, but unfortunately due to the FPGA was not available, like I think like 6 months or 8 months ago, like he was not able to populate like four boards. So he has four
Mhm.
boards lying around which are like completely populated except for the FPGA. So he said like, it's like I don't need them immediately, so I can give you those boards. But like, his project paid for those four boards. So to offset the cost, maybe like, we can just give him like eight FPGAs, so that like in the future, if he gets more boards, like he can use the FPGAs to populate those boards, and he can use it in the future. Because like you
I
can't
see.
you can't pay individual in LBL, right? You need to pay a project, and like usually like a project and project won't accept any money. So I think this is the
Yeah,
reason.
yeah, no, and I totally
Mhm.
understand,
Yeah,
Tarun. So,
yeah.
Tarun, I mean, I would like to give, if you don't mind, I'd like to say something on the FPGA board,
Hmm.
right? So, I know you're working on this board, but
Yeah,
my preference would be to redesign that board, right, to tailor for what we are doing.
correct.
And
Yeah.
the best way to do that is we the BOP is actually trying to get AMAT and other people, IMEC and other people,
Hmm.
right? When
Yeah,
everybody is on board, we'll review this board architecture to see if everyone agrees with that, but like what their feedback. And based
correct.
on that, either we can keep
Hmm.
it or we can actually redesign this board, right?
Sounds good. Yeah. Uh-huh.
So until then, what we'll do is actually we can buy the FPGA. FPGA anyway we would need, and we agree that this is the right FPGA to use,
Hmm.
right?
Yeah.
So
No, yeah.
let's keep that FPGA, and since you have a lot of knowledge on this FPGA, we'll go ahead with the same FPGA that is used on Cryo Captain board, and
Okay.
then we can buy the FPGA in stock, and then whether to purchase the board will defer it until we
Okay.
have all the people on board.
Sounds good. That's also fine. I think that's also fine. Yeah, I don't think that's going to be an issue at all. So we can
Okay,
do that.
perfect.
Yeah, yeah. And also, I just want to like mention, like if you pull up the picture of the board, right? For example, the one I sent you.
Hmm.
Or I could share my screen if just
Yeah,
give me
please.
one
Yeah.
second. Yeah. Oh, can you see my screen?
Um. Yeah, I can see a screen. Yeah, go ahead. Yeah.
Yeah. So this
Top.
is
Yeah.
Yes, top and the bottom, right? So top we have like SODIMM connectors, two connectors, At the bottom, there are like these RF connectors, which can plug into any other board, for example.
The board. This
Yeah,
what is the name of this connector, Tarun? This one.
it's a Samtec RF connector. I don't exactly know. So it's a high speed connector basically. It can go up to like 1 or 2 gigahertz, I think. And these are specifically used for analog for this board, but they are connected to like GPIO pins, and we can. So for
Okay.
example, like if
Okay.
we have a
No, actually, I
mother,
like
yeah.
the
Mhm.
connector. The connector actually looks pretty good compared to the one I've been
Mhm.
thinking about,
Yeah.
or familiar with. Just can you actually find what the port number for this? Then we'll try to locate the data sheet.
Yeah, hold on. Actually, let me actually try that right now. Just give me one
Yes.
second. Uh,
Yes.
so
Oh, is
it's
that okay? The connector actually is small. That looks
yeah,
pretty attractive,
yes,
right? And then
yeah.
let's see what the speeds and feeds are, and
Hmm.
how many IOs can we get, and all that.
Yeah. Uh, so it is called CLE. Okay, so let me. Okay. Okay. I just sent you uh, a link on the chat. So that's the connector. Yeah.
Mm, oh, okay. What family of this connector? And this actually survives multiple insertions and removal, right?
Yes, this surveys multiple insertion removal as well as like
Very small.
like a cold like cryostat temperatures. That was one of the main reasons. It says
I
operating
see.
-55, but like I think they've tested it like at like -180. So I think
Okay.
yeah.
And this is actually what 128 positions, right? 128
Yes, yeah,
positions.
this is 128, yeah.
Okay, this is called series. It's a board-to-board connector. Okay.
Hmm. Yeah. So this FPGA has two of those. So basically, essentially, like essentially it's 200 pins, approximately to 200 to 50 pins, which can be used as we can basically ignore the SO-DIMM and then use these connectors to connect to the motherboard at the bottom and then like
Yeah.
do any GPIO. So yeah, I know you were concerned about like how do we use SO-DIMM for this one, but we can use these connectors instead. Yeah.
Yeah, and that is where I have the thing. SODEM, we have to have that board plug in just to do a loop back,
Correct.
right?
Yes. Yeah.
But I think your thinking is actually we'll put additional peripherals we want. We can have a pluggable mechanism,
Mm-hmm.
correct?
Correct. Yes.
Um, yeah, I would like to think a little more about it. I think the idea itself is good, but how complex is it to put attach the boards?
Mm-hmm.
And your idea is you can expand that FPGA if you need to, correct, without redesigning the FPGA board.
Correct. There are like two 128 pin connectors connected to the FPGA board. So we
Hmm.
can we can use those directly. Uh,
No, so the way it works is this is what I understood from a previous description. So
mhm.
FPGA, you have IOs coming out. The
Yes.
FPGA IOs are going to that your that the SODIMM connector, correct? It's not directly connected to the bottom connector. From SODIMM, your connection to the bottom. That's correct.
From correct. Correct. Yes.
And then if you let's say if you're not using anything on the SODIMM, you just
Mhm.
have to plug a board so that it makes the connection from the FPGA to that bottom side connector, the board to board connector, correct?
Yes. Yes. Yeah. That is correct.
So yeah, um, no, that is an interesting idea because that gives me an
Mhm.
option for expanding. Let's say I want to put some ADC or
Mhm.
some kind of peripherals I want to add to the FPGA. I
Mhm.
can attach to
Use
that,
the
right?
SODIMM. Yeah.
Uh,
Yeah. And
Otherwise,
then,
it'll be like a pass through. I just have to design only
mhm,
the SODIMM board without
mhm,
redesigning the FPGA board.
correct.
And currently, what you're using for the SODIMM board? What are you? What peripherals you have there?
Oh, so for the SODIMM board, I think like we have like ADCs right now. So this is mostly used for ADC. So it's like, see these high speed connectors. Oh, let me share.
Mhm.
Sorry again.
And do you have
So
any connector on that
mhm.
board itself? That SODIMM board, do you have any connector from the?
No, so basically, the analog input comes here through these connectors, through the
One second. One
Samtec
second.
connectors, and then it goes.
Sorry, one sec. Hold on.
Mhm.
Can you show me what is the analog connector you're talking about?
Oh, these Samtec
Oh, okay, okay,
connectors, yeah, the
okay.
one I just shared, right? So
Mhm.
these are used for like analog inputs, for
Mm,
example,
mm,
for this exam for our application here,
mm,
and then it goes to the SODIMM board, which has like ADCs on top, and then the
mm,
digital data is going to the FPGA. And then
mm.
FPGA uses the gel interface OA is basically Ethernet connection, and then we read out the data here through the Ethernet connection.
Ethernet.
Yeah.
Where is the Ethernet kind of jack? There is no Ethernet jack
So
here.
no, it's basically there's another board. I think I added a picture. I don't have the picture here.
I
Let
mean, you
me.
have a third board. You have a base
No.
board, and you have two SODIMM, and then your third board.
Yes. Yeah. So
That's
let
the
me ask.
gel interface.
That's a gel interface. Yeah.
The gel interface board will have the RJ45 connector for Ethernet out, is it?
Correct. Yes. So let me just try and get that. Hold on. Just give me 1 second. I'll pull up another picture. I think it's in the uh, uh, I think it's in um, okay. There you go. It's here. So if you um, so if you see this picture which I put, so you see this, the red board, that's the gel. Can you see my screen?
Yeah. So that's the gel board. Okay, okay. It's
Yes, yeah.
required like that
So
on
this will
top.
be,
Okay,
yeah, this will be plugged on top. Yeah,
I see. That actually brings out Ethernet out. Okay.
yeah. So there you go. So basically it goes at this connector here, and then we see, and then you can get the Ethernet out.
Okay. And if you use that board, then you don't have only access to only one SMA. Okay. Oh no, you have multiple SMAs. What is the SMAs used for? These are clocks.
These one, I think these are clocks, yes. So
So
external, yeah, so it
30.
is, yeah, so it is clock and stuff, yeah. And this is like this is for the this pin is for the Ethernet clock, Ethernet board, this
And
clock.
how much is the cost of the board you mentioned?
It's basically $1,500 for complete board, including the FPGA. So that's
Uh,
what Marcos suggests. Marcos says it's around like it's
okay,
around
okay.
that ballpark. Yeah, 1,500 for the complete board
1,300 for
with
the.
yeah with FPGAs with the FPGAs. So
I,
because he's giving us boards without the FPGAs, then he's basically asking like $1,000, I think, for each board, maybe. Yeah.
okay, okay. And how many? Do you know how many layer board this is?
I think this is I'm not sure. It probably is 8 or 12. I think I'm not sure. It's
Okay.
pretty thick
Okay, no
from
problem.
what I see. Yeah, yeah.
Okay, I think from the feature wise is good. Right, you have a lot of hooks to add,
Mhm.
subtract, what you want to do. There's a lot of things at play. So only thing that I would actually say is the cost. Then, right, what boils down
Mhm.
the cost. The $1,005 includes all this SODIMM and the gel interface connector, everything included, or what?
No, just this board. Yeah, so SODEM is like you need to design the SODEM if you want, however you want. So it's application.
So that will be a separate one, right? Okay.
Yeah. So that is I don't think like they design it. So they basically design for their application specifically. So obviously it has like its own like ADCs and stuff like that. But and
Mm-hmm.
and SODEM like I think we need to design it if you
So
want.
my other question is, Tarun, would they be willing to open source the schematics and for this
I
book layout
I
for this?
I I did ask that, and Marco said like that most likely will, but like it's going to be a conversation. I think like we need to like involve everybody, but like it's most
I
likely
see.
possible. Yeah,
I see. Okay. Um,
yeah, because Fermilab is a non-profit organization, so it's like
right, right.
yeah
And you
they
also mentioned about the size, right? XY dimensions. What is that XY dimension is?
I think
Right?
it's maybe like 4 inches by 4 inches, I think. But I need to double check. I'm sorry. I
No,
said
no, that's
I'll check,
okay.
but yeah, but
Must be
yeah.
asked a question a lot of times. So
Yeah, yeah. It's
uh,
pretty small. Yeah, it's not
almost
too big. Yeah.
4 inches. Millimeter. Okay. Yeah, that's about 100 by 100 millimeter.
Probably, yeah.
So 100 by 100 millimeter. That's within that our target, right? I think we defined some dimensions
hmm
for.
Yeah,
I think I don't remember. Probably it's 150 by 150. I think so. It's
I
very
think that's what we were thinking. But like, yeah, this definitely under that. This is a pretty small board, yeah.
mm.
But thing is like, if we add SODEM, it's like basically vertically we need to connect everything. So yeah,
Yeah. No, vertical
yeah.
connection is not a problem.
Mhm.
Okay, I think let's review with the other people as well. The feature wise, connector wise, everything looks pretty good to me. Um, and only thing is, we want to target the whole platform cost, right?
Correct.
Maybe
hmm
say 2,000 or 3,000, right? This is itself is the bulk of the cost,
Correct. Yeah.
right? I think we should get feedback from others as well,
hmm
and decide on a direction.
Sounds good, JP. I think yeah, whatever like it works. I mean, like at least for now, if you want anything immediately, there are 4 boards available to like do any
Mm.
testing.
Mm.
But your plan is fine. Like, we can you can buy the FPGA, and then like future we can like try and design the board ourselves, and
Mm.
then take a look at it. But yeah,
Yeah, yeah. I mean, the advantage you have is everything is ready made. You have software available for this board, right?
correct.
It's,
Yeah. The cost includes the software, by the way. That also is included. So they will give you a firmware which has like which includes the gel interface, like the Ethernet Ethernet data transfer and stuff, because and as well as like the very basic this one
yeah.
all the constraints
Actually,
and
in
stuff.
our
Yeah.
application,
hmm
we don't
hmm
really need a strictly
hmm
um, Ethernet because it's not like super high bandwidth that we need to probe,
Correct.
uh,
Yeah. But
right?
yeah, but that's included in the cost, right? So it's like that's what
Yeah.
they designed it for. Yeah.
No, no, I understood.
Yeah.
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 That's why let's see. Well, let's see what others are thinking about this,
hmm
and then we'll come up with a definition for it.
Sounds good, JP. Yeah, whatever you decide, I think that's fine. I mean, yeah. So, yeah, this is an option, right? I mean, like we can.
Certainly, certainly.
Yeah,
This is a good
yeah.
inspiration that we
Mhm.
can leverage from this,
Yeah.
right? The connected design, the board size,
hmm
and everything, right? So let's start off with that,
Yeah.
right? And then see if any more optimization needs to be done, or we can use this as it is for the first version. Maybe
Yeah.
it's possible that we'll reuse the same for the first version, and the
hmm
next version we kind of tune it,
Correct. Okay. Yeah.
right? That is also another possibility because that will get us going faster,
hmm
right? And then the platform stabilizes, then we can optimize the cost, optimize the interfaces we need.
Yeah. Yeah.
That's another option.
Mm.
Okay, Tarun, this helps. So
Mhm.
I think that uh, what is the trend idea is good, that we can order FPGA and then we'll decide on a direction.
Correct. Okay. Yeah. I think that's a good idea. Yeah.
I think Bobby will be here next week, so we can
Mhm.
touch base more with him. And then he's also trying to set up meetings with the other people as well. So I think like IMAC you mentioned, Fraunhofer
Mhm.
and AMAD. So I think we can hit at least three of these people.
Sounds good. Yeah.
Okay, Tarun, anything
All right.
else?
That's about it, JB. I don't have any more updates other than this.
Okay, perfect. Thank you, Tarun. Yeah,
Okay.
talk.
No problem.
Yeah, bye.
All right. See you. Thanks. Bye bye.